Unit 6, Day 1, Vectors, Part 1. Now, whenever you're constructing a vector, it must go from, if we're going to use PQ, if we're going to graph PQ, it must start at P and end at Q. So let's go ahead and plot the coordinates of P, which would be -2, 3. That is plot P, and then Q would be 3, 5. Okay, so like I mentioned, if your vector is vector PQ, then we must start this direction and then draw an arrow just indicating where it's going. And I could put a Q there. Okay, so we have graphed vector PQ. Now we need to find the magnitude of PQ. I'm going to show you the way that we're probably going to do it most of the time. Now, these are coordinates, remember, X, Y, X, Y. If you have a set of coordinates, you always want to start with the terminal and then subtract that from the initial. And I'm going to start with coordinate X. So 3 minus -2. And 3 minus -2 would be 5. Now let's take the Y coordinate here of the terminal side 5. Subtract that from the Y coordinate of the initial side 3 to get 2. Now, hopefully you have noticed that I've made my parentheses pointy. That's what's called a component vector. This vector consists of components 5 and 2. Now, another way that you can find your components is if you have a graph, you could construct a triangle. But we're rarely going to have a graph. From here to here, that is 5 units. From here to here, that is 2 units. In order to find the magnitude, we use the Pythagorean theorem. So we would do 5 squared plus 2 squared and set that equal to c squared, and then start doing your math. Square root. So we have a magnitude of the square root of 29. And this is quite possibly some of the more difficult stuff that we'll be doing today. We're just going to be finding our component vector and finding the magnitude. We'll also be doing direction too, but we'll get there in just a second. Okay, here they give you the definitions of the components of a vector, position vector, example 2. There's really not much we can do here. Don't worry about this part. And then in order to find the direction of a vector, here are those directions. Here are the formulas. We've actually already done this before. We're going to have to go back to SOHCAHTOA. But I find it's easier to learn this by actually doing it. So let's go ahead and go to side 2 of our notes. Example A, we have to find the direction and magnitude for the following vectors, and they say to draw a picture. Now, just to make this visually easier to see, I have a giant graph, a bigger graph that I have put on a piece of paper here. You will not be provided this stuff. You would have to just kind of sketch a graph on your own. So you can do it this way. You will rarely be given an actual coordinate plane. Okay, so here we go. If we're going to find the direction and magnitude for the following vectors, they have given us the component vector 3, 4. So we would want to plot that first. Okay, so there's our vector. They've already let us know that it consists of components 3, that's our x value, and 4, that's our y value. So we need to find the magnitude first. That's just Pythagorean theorem. So we have a magnitude of 5. we have a magnitude of 5. Now, we need to find the direction. Angle theta is here. We have opposite, we have an adjacent. So that's where TOA comes back in handy. We will need a calculator for this following part. So if you don't have one, go ahead and get one, please. Now, in order to find our direction, it's going to be our angle theta compared to the positive x-axis. If it's in quadrant 1, that's the easiest one to find. So the way that we do that, remember, TOA, that's tangent. Tangent of theta, or tangent of x, is equal to opposite over adjacent. But since we're solving for an angle, we have to use inverse tangent. And then your 4/3 and your x value, they just switch places. So now we go into our calculator and do second tangent 4/3 to get a value of 53.130. It does not tell us where to round. And when that's the case, round to 3 decimal places. So our direction is 53.130 degrees. Example B, we have the component vector -2, 5. So let's plot that. So in order to get to the end of our vector here, we would have to go left 2 spaces, up 5 spaces. And we can now find the magnitude by using Pythagorean theorem. But we have a magnitude of square root of 29. Now, in order to find the direction, here's angle theta. I'm going to go ahead and do inverse tangent. Our opposite is 5. And our adjacent is -2. Now, I'm going to put +2. You could put -2 if you wanted to. It doesn't matter. It's just, I don't want my answer whenever I go to plug this into the calculator. I don't want it to be negative. So I would just, whenever we're finding inverse tangent, I would just use positive values. Okay, so let's go figure out what this is. Second tangent. Okay, we get 68.199. Now remember, y'all, we have to find the direction from where angle theta is in relation to the positive x-axis. So this is actually the rotation we need. This is the direction. Our answer is not 68.199. It is 180 degrees minus 68.199. So 180 minus, scroll up and hit enter so you can copy and paste down that answer, and then enter again. So our direction is 111.801 degrees. Example C, we have component vector -1, -2. In order to get to the end of our vector, we would have to go left 1, down 2. We can now find magnitude using Pythagorean theorem. So we have a magnitude of the square root of 5. Now let's find our direction here. Here is angle theta, inverse tangent. Remember, we want to use positive numbers here, at least I do. Opposite would be 2 over adjacent, which would be 1. And that will give us our direction. At least it'll help us find the direction because we are not in quadrant 1, we're in quadrant 3. Okay, second tangent, 2 over 1 or just 2. And we have 63.434 degrees. Now remember, we are not in quadrant 1, so that's not our answer. We need the answer in relation to our positive x-axis. So this is not really the answer to our problem here. It helps solve the problem. We need this direction here. In order to do that, we would need to do 180 degrees plus this amount that we just solved for. So we have a direction of 243.435 degrees. Example D, we have component vector 2, -6. In order to get to the end of our vector, we would need to go right 2 and down 6 spaces. There's angle theta. Let's find our magnitude. Now, the square root of 40 will reduce. The square root of 40 you could also write as a decimal. I don't really care what you go with here. I'm just going to keep the square root of 40. You have a magnitude of the square root of 40. Okay, let's find our direction. So inverse tangent. Opposite would be -6 or 6 over the adjacent, which is 2. We solve this, we get our direction. Actually, no, we don't. It helps us find our direction because we are not in quadrant 1. Okay, second tangent. 6 over 2 is 3. We get 71.565 degrees. Now remember, that's the angle here, but we need the angle from here to here. So we would have to do 360 degrees minus that amount that we just solved for to get an answer of 288.435 degrees. For example A, what we're doing here is we're just trying to figure out if these vectors are equivalent or not. So we're going to start with coordinates R, S. Now remember, R is where we start. And S is where we end. So whenever we're finding component vector, you need to do end minus start. So let's start with finding the x value of our component vector by doing -1 minus -4. 1 minus -4 would be 3. Okay, same process, but this time let's do 6 minus 2 to get 4. So the component vector of this one is 3, 4. Now let's do the same process, but this time we're going to compare our data with vector OP. The end is 3 minus the beginning x value of 0. Our our end y value is 4 minus the beginning y value of 0. Since we have the exact same component vectors, yes, these are equivalent. Why don't you practice this next one on your own and see what you get? And then the last page, we're going to perform operations with vectors. We've done stuff very similar to this before. This really isn't too hard. So we're doing 2 times u. U is component vector 2, comma 3. So I would just start with a 2. And then substitute for u our component vector 2, comma 3. And then distribute. 2 times 2 is 4. 2 times 3 is 6. So that's your answer for A. 4, comma 6. Okay, for B, we have negative W. So start with a negative. Component vector W is here. So let's do negative 2, comma 1. Distribute that negative. To have a final answer of 2, comma negative 1. Example C, we are now doing u plus w. Component vector u is 2, comma 3. Component vector w is negative 2, comma 1. Now we're adding here, but you want to add like terms or like values. So we're going to take 2, add it to our other x value, negative 2, which will give us 0. Take y value 3, add it to the other y value 1. 0, comma 4. And then example D, we have negative 2 times component vector u. And we are subtracting that from 3 times component vector v. Okay, negative 2 times 2. Negative 2 times 3. I'm going to start by just distributing the 3 first. So 3 times negative 6. 3 times negative 3. And now I'm going to bring down that minus sign. Okay, let's now build our final answer by doing our operations with our x values first. So I need to do negative 4 minus negative 18, which would give us positive 14. And now our operations with our y values, negative 6 minus negative 9, which would give us 3. And we're done.